ever felt that familiar dread? You've got this pile of data, maybe a download, a report, whatever, and just getting it usable, cleaning it, even just opening it feels like such a slog. You're just wishing there was an easier way, maybe faster, maybe less error prone.
Oh, absolutely. It's a feeling I think pretty much everyone who works with data knows well. Data drives everything now, but honestly, the way it's packaged, that can be the biggest hurdle to actually using it.
Right. So, okay, let's try and cut through some of that confusion today. We're going to take a deep dive into two file formats you probably deal with all the time, maybe without even realizing it. The simple CSV and its much more powerful cousin, Parquet.
Yeah, and based on the articles and discussions you shared, our goal here is to really unpack these, figure out what makes them work, their strengths, their weaknesses, which can be pretty surprising sometimes, and where you see them in the real world. And hopefully help you figure out, when to use which one for your particular data job.
Okay, let's dive in. When we talk data files, I think for a lot of folks, the first thing that springs to mind is probably that humble.csv file.
Exactly. We really have to start there. CSV. It stands for comma separated values. And really, at its heart, it's just a plain text file. Nothing more complicated than that.
Plain text. So you can literally open it in, like Notepad or text edit, just like a regular document.
You got it.
That's got to be a huge part of why it's just everywhere, isn't it?
It really is. The structure seems super simple on the surface, right?
Yeah.
You've got your values. They're separated by some delimiter, usually a comma, and then each new line is a new row. It's just built for basic tables, rows and columns. Straightforward.
And that .csv file extension kind of signals that, hey, probably a table in here.
Precisely. But, it's funny, the name is comma separated, but one of the first things you notice looking at the research is how often that's, well, not strictly true. You see semicolons all the time, pipes, tabs, even quotes sometimes acting as the separator.
Okay, hang on. That sounds like it could immediately cause headaches. What happens if your actual data, like someone's comment or an address, has a comma in it? Or what if it has a quote mark? Or even worse, like a line break inside one piece of data.
And that is the fundamental challenge with CSV. It really is. The common fix is to wrap those tricky values in quotes, but then you hit the next wall. What if the data also has quote marks inside it? How do you handle that?
Well, it often depends entirely on whatever software made the file or the software that's trying to read it. It's not quite as simple as plain text makes it sound.
Ah, okay. So the simple idea leads to kind of messy reality, inconsistency. That feels like a really key point.
It absolutely is, yeah. Despite seeming simple, real-world CSVs can be surprisingly inconsistent.
But still, CSV is it's everywhere. Yeah. So even with those potential problems, what makes it so darn appealing? Why is it so common? Its superpower really is compatibility. It's kind of the universal translator for data. Almost every piece of software out there, databases, programming languages like Python with pandas or R, all the spreadsheet programs, they all get CSV. Think about Excel, Google Sheets, Airtable. They all handle CSVs natively.
So if you need to get data from system A over to system B, CSV is usually the easiest way to make them talk.
Exactly. That almost universal reach is its biggest plus. Yeah. And then there's just the simplicity, or perceived simplicity. The row column thing is just intuitive. And because it is just text, someone who isn't super technical can open it, look at it, maybe even, fix the quick typo with just Notepad.
And I guess for certain things, it's pretty efficient too. Lightweight.
Very much so.
Yeah.
Yeah. There's no fancy formatting baked in, so the files themselves are usually quite small. That makes them easy to zip up an email, quick to generate, quick to store, quick to send. If you just need to dump some data out fast or share a small list, CSV is often, perfect.
So where do these things actually pop up most often, like day to day?
Well, the research highlights some really common uses. One of the biggest is just moving data between different places, exporting from a database to maybe look at in a spreadsheet or pull into a Python script for analysis.
Right. Or like if you're switching software, moving from one CRM to another, maybe. CSV is probably how you'd get your customer list across.
Definitely. That data migration piece is huge. Another big one is uploading lists of contacts into email tools like SendGrid or maybe customer data into Salesforce, that kind of bulk upload task.
And it's not just moving data, right? People use them for basic analysis, simple backup.
Oh, yeah. Backups, generating reports, especially if they're just simple data tables. And actually, increasingly, you see CSVs used for storing training data for machine learning models.
Yeah.
Easy to load into libraries like scikit-learn in Python.
So yeah, it's kind of the default for countless basic data jobs pretty much everywhere.
Absolutely. Almost every industry.
Okay, so Simple, compatible, great for quick stuff, smaller data. But you mentioned those inconsistencies earlier. Where does that simplicity start to um, break down, especially when things get bigger or more complicated?
Yeah, this is where you really start to feel the pain. And the research is pretty consistent on this. The biggest headache is that there's no strict universal standard that everyone actually follows. There is an official standard, RFC 4180, but most tools, and critically, this includes Microsoft Excel, they don't fully stick to it.
Wait, so the simple structure gets interpreted differently by different programs.
Exactly, and that leads to all sorts of inconsistencies and makes CSVs incredibly prone to errors, both from the software side and the user side. Think about it, you get duplicate headers, or maybe missing values, throw off all the columns after it, text showing up where numbers should be, weird character encoding issues. It's the classic data cleaning nightmare feel.
Ugh, yeah. The dreaded error on line 53 when you try to import something, I've definitely been there.
That's the one. The research mentions this specifically. Applications trying to import CSVs either have to be super forgiving, which can hide problems, or they implement strict checks, which then throws up those errors that frustrate users, creates support tickets. Sometimes people just give up. And fixing it often means digging through the file manually.
And it sounds like size becomes a major bottleneck, too.
Oh, absolutely. CSV just doesn't scale well. Most common tools, libraries, they really start to bog down, or performance just tanks once you get over maybe 1 million rows. And a lot of tools try to load the entire file into memory at once, which is just impossible for really large data sets.
And the tools themselves have limits, don't they? Like Excel can only handle so many rows.
Exactly right. Excel hits a wall around 1 million rows. Google Sheets has a limit on total cells. I think it's 5 million per sheet. Trying to actually analyze or transform big data sets within those tools using CSVs just becomes impractical or, impossible.
And there was also that kind of surprising security risk mention.
Oh, yeah. CSV injection, sometimes called formula injection. It's a clever, nasty little trick because spreadsheet programs are smart, right? They see something starting with an equal sign and think, a formula. So someone can hide malicious code inside a CSV file disguised as one of these formulas. If an unsuspecting user opens that file in, say, Excel, the program might just execute that code.
Wow. You really wouldn't think a simple text file could carry that kind of risk.
It's a good reminder that it's not just the file format, it's how the software interprets it. And that interpretation can definitely open up unexpected vulnerabilities.
Okay, so CSV, great for simplicity, small scale, basic sharing. But it struggles with consistency, errors, big sizes, and even has this sneaky security issue. That feels like the perfect transition to talk about something built to tackle those bigger data challenges. Parquet.
Let's do it. Let's bring in Parquet. And it's a completely different beast. It was developed by Apache, and it's not a simple text file at all. It's what we call a columnar storage format. And that's the absolute key difference compared to CSV, which is row-based.
Okay, hold on. Columnar versus row-based. So CSV stores like row 1, col 1, row 1, col 2, then row 2, col 1, row 2, col 2, row by row. Parquet stores all the col 1 values together, then all the col 2 values together. Is that right?
Exactly. Think about your spreadsheet grid. CSV stores it reading across the first row, then the second row, and so on. Parquet basically flips it 90 degrees. It stores all the data from the first column together as a block, then all the data from the second column together, then the third.
Got it. Okay. And straight away, that tells me you probably can't just open a Parquet file in Notepad and see anything useful, right?
No, not a chance.
Yeah.
It's absolutely not human-readable like that. It's structured binary data, specifically designed for machines to process efficiently. You need special software or libraries to actually read and make sense of it.
Okay, so if I can't just peek inside it easily, what's the big win? Why go through the trouble of using Parquet?
Well, that columnar structure unlocks some really significant advantages, especially when you're dealing with large amounts of data or doing analytics. The first big win is storage efficiency and compression. Think about it. Data within a single column is usually all the same type, all numbers or all text or all dates. And often it has similar values or patterns. This makes it incredibly effective for compression algorithms. Things like Snappy, gzip, zstandard. They work really well on columnar data.
And the research you looked at showed this makes a massive difference in file size compared to CSV.
Oh, a dramatic difference, yeah. The benchmarks consistently show Parquet files can be way, way smaller, often up to 10 times smaller, sometimes even more depending on the data. Think about what that means. 10x less disk space needed, 10x faster to transfer over a network. Those visual comparisons showing Parquet file sizes versus CSV, especially uncompressed CSV, they're really quite striking.
That's huge savings. Okay, but storage is one thing. How does it make the analysis faster?
right? And this is probably the killer feature for anyone doing serious data analysis. When you run a query, say, you want to calculate the average sales price or count customers by state, you usually only care about a couple of columns, right? Sales price and state in that example. Now, with a row-based format like CSV, even if you only need those two columns, the system also has to read all the data for every single row just to pick out those two values. With Parquet, because sales price is stored together and state is stored together, the system can say, okay, I only need to read the sales price column data and the state column data. It completely skips reading all the other columns.
Ah, okay. So you're not wasting time and processing power reading potentially gigabytes of data you don't even need for that specific question.
Exactly. This concept is often called predicate pushdown. The query engine can push down the filtering, like Clear State, California, or the column selection right into the reading process itself. It lets the system skip over massive amounts of data it doesn't need. It massively boosts query speed and cuts down on the amount of data being moved around.
That makes total sense for analytics. What about data quality? You mentioned CSVs can mess up data types or have those delimiter issues. How does Parquet handle that?
Parquet pretty much solves a lot of that because it has the schema, the structure of the data, baked right into the file itself. It includes metadata that says, okay, this column is called order date, and it's a date type. This one is quantity, and it's an integer. Mm-hmm. It knows the names, the data types, and proper types, like actual dates, timestamps, decimals, not just text, and the overall structure. This gets rid of all the ambiguity and guesswork you have with CSV. It keeps your data types correct, so numbers stay numbers, dates stay dates. And because it doesn't use delimiters to define structure, things like commas or new lines inside your data are just not a problem. It also helps prevent issues like staggered rows where a row gets misaligned.
So it's much more robust. It kind of describes itself, the data it holds.
Much more so, yeah. And another point, unlike CSV, which is basically flat tables, Parquet can handle more complex nested data structures pretty efficiently. Things like arrays or maps or structs, basically data that might have lists or key value pairs within a single record. Parquet handles that without forcing you to flatten everything out first.
And this whole columnar thing, the efficiency, it sounds like it was designed for big data platforms.
Absolutely. Tailor-made for them. Its structure is perfect for parallel processing in distributed systems like Apache Hadoop or Apache Spark. These systems can easily break up the work. Different machines can process different columns or different chunks of rows within columns all at the same time. It scales incredibly well, whether you have terabytes or even petabytes of data.
And does it play nicely with those big data tools?
Oh, yeah. Native support, seamless integration. If you're working in Spark, Hadoop, Hive, maybe using cloud services like AWS Athena or Google BigQuery, or writing code in Python, Java, R in that kind of environment, Parquet is usually a first-class citizen. It just works.
Any other sort of advanced capabilities worth touching on?
Well, the sources mentioned a few things. Efficient data partitioning is one, basically organizing your Parquet files into folders based on certain column values, like maybe year and month, which can make queries even faster if you filter on those columns. There's also support for columnar encryption, which adds a layer of security. And some tools, like Spark, can handle schema merging, managing slight variations in the data structure over time, although they can be a bit complex and sometimes costly to run.
Okay, so Parquet sounds like a real powerhouse, built for scale, speed, data integrity, especially in those analytical jobs. Given all that, when is it clearly the way to go?
The message from the research seems pretty clear. You reach for Parquet when you're dealing with datasets that are just too big for traditional tools using CSV, when you're pushing those limits or going way beyond them.
And when your main goal is analysis, right?
Yeah.
Running queries, aggregating data, filtering down to just a few columns.
Definitely. That's its sweet spot. And crucially, when you're working in those big data ecosystems, data lakes, data warehouses, platforms running on Spark or Hadoop or cloud data platforms, also, anytime that data integrity, making sure your data types are preserved correctly and avoiding all those messy CSV parsing issues are really critical.
Parquet sounds amazing for those scenarios, but, nothing's perfect. It can't be the best choice for everything. What are the downsides? Where does it fall short?
Yeah, good point. The most obvious one we touched on is that it's just not human-readable. You can't just email a Parquet file to a colleague and expect them to easily open it in Excel and browse the data. You need the right tools or libraries installed.
Right, so that dead simple accessibility of CSV, that's gone.
That's the main trade-off, yes. Another thing is that while reading data for analytics is super fast, writing new data, or especially updating existing data, can sometimes be a bit less efficient than with a simple row-based format. If you need to change just one value in one specific row, you might technically need to modify data across several different column chunks within the file structure.
Ah, that makes sense. It's optimized for scanning columns, not necessarily for quick, small, random writes to individual records.
Exactly. And related to that, for queries where you actually do need to fetch all the columns, but only for a very small number of specific rows, like looking up one single customer record by its ID, having to potentially pull data from many separate column files might actually be slower than just reading one continuous row from a CSV file.
Interesting. So if your main job is just fetching full single records, CSV might occasionally win.
It's possible, yeah. Depend on the exact use case and how things are set up. Parquet really shines when you're scanning and aggregating across many rows, but only needs some of the columns. And, there's just a steeper learning curve compared to CSV. It's more complex under the hood. You need a bit more understanding of things like compression types or partitioning to really use it optimally.
So definitely more complex, requires more specialized tools and maybe a bit more know-how than just double-clicking a text file.
For sure. It's really a format built for systems, for machines first, and maybe humans second, whereas CSV is arguably the other way around.
This really drives home that point, doesn't it? There's no single best format here. It's all about trade-offs, about picking the right tool for the job you're doing. How should someone approach making that decision for their own data?
Yeah, it really boils down entirely to your specific situation. What does your data look like? How big is it? What do you need to do with it? Who needs to interact with it? CSV is fantastic for its simplicity, its readability, that near universal basic compatibility, and just how easy it is for quick tasks. It's great for smaller data sets, simple lists, maybe prototyping, situations where someone might need to manually look at the data, and basic import-export where scale and strictness aren't the biggest concerns.
And then Parquet steps up when those CSV limits start to bite you.
Precisely. Parquet is your go-to for performance, for really efficient storage, for strong data integrity, and for handling complex data structures, especially at scale. It's the format you choose for large data sets, for heavy-duty analytical work, and when you're plugging into those modern big data frameworks.
So it's not really about one replacing the other entirely, is it? It's more about understanding they have different strengths and picking accordingly.
Exactly right. It's like having different tools in your toolbox. You wouldn't use a hammer for everything, right? You need to know when to grab the screwdriver or maybe the power drill. Same idea here.
We've definitely covered a lot of ground here, from the everyday, sometimes frustrating, but totally ubiquitous CSV, all the way to the powerful, efficient, big data optimized Parquet.
Yeah, and understanding these differences isn't just academic, is it? It's really fundamental to working effectively with data today. It helps you move beyond just, fighting with files and start making strategic choices about how to store and process your information to be more efficient and get more accurate results.
It really does change how you think about handling data tasks. And maybe as you think about your own data challenges, here's something to mull over. Does the file format you choose just change how you store and access data? Or does it fundamentally shape, maybe even limit, the kinds of questions you can efficiently ask